Are you all back? Okay. So now we will start with another this thing that is called conservation of momentum. What is momentum? Momentum is given by mass into velocity. Yes.
Velocity.
Okay.
Yes.
If I say that you have a football, you have a cricket ball, and there is a football. Okay. This is 100. Let's say it is some 100, and this is, let's say, 50. This is moving at a speed of 10. This is moving at a speed of 10. Yes or no? See, both might be moving in a same velocity, but the one which is having the highest momentum will hurt you. The cricket ball hitting will hurt you more than the football because the momentum is high. Understood? Yes or no?
Yes, sir.
So
Yes, sir.
this is the momentum. If I say what is momentum in an isolated system, the momentum always remains constant. Means if at all there are two objects colliding each other, this is called initially what is the momentum, because initially this might be moving at a speed v1, this might be moving at v2, and later on, let's say both are got a different speed, means this one got v2 and this one got v1. Okay, but the momentum always remains constant. Whatever, if I say there are two objects m1 and m2, when they collide, the momentum is m1 into v1 plus m2 into v2. This is during the initial part, during the collision, and after the collision it becomes m1 into, let's say, v3 and m2 into v4. The velocity got changed, but remember, initial and the final momentum will always remain constant, because the mass, we don't know, mass might be broken, we don't know anything, but remember, the initial momentum and the final momentum is always remain constant. Okay, that means there will not be any change in momentum. There will not be any change in momentum. So if I say that P is equal to mv, there is another formula I can say for the force. Net force can be written as delta P by delta T, or change in momentum per unit time. Change in momentum per unit time. You'll say how? I can prove it. See, what is force? Force is equal to mass into acceleration. Correct? Yes or no? Force is mass into acceleration.
Yes, sir.
So when I say that momentum force is delta P by delta T, so I can say dP by dt. So I can write this as, what is P? P is mv. So I can write d by dt of mv, which I can write as d by m is a constant, will come out m into dv by dt. What is dv by dt? What is rate of change of velocity per unit time? What is rate of change of velocity per unit time? Acceleration.
Acceleration.
Yes,
Yes, sir.
mass remains constant. So hence we can say that force is equal to dP by dt. If somebody asks you how, you say that dP by dt. What is P? P is mv. M is constant, will come out. So dV by dt, we know dV by dt is what? Rate of change of velocity per unit time. Velocity per unit time is what? Acceleration. Now we got this quantity to be acceleration. We know force equal to mass into acceleration. Hence, dP by dt is equal to force. Clear or not?
Yes, sir.
Yes?
Yes, sir.
Okay. So if I say there are two objects which is hitting each other, okay, one is 5 kg, one mass is, bigger mass is 5 kg and smaller mass is 0.2 kg. I don't know the velocity. Bigger mass, I don't know the velocity. I want to find out velocity is equal to 200 meter per second. So can we find this one? Velocity how? mv, okay, mv plus mv is equal to, I can, okay. What is this one? Pi is equal to pf. That means initial momentum is equal to final momentum. Yes or no? Yes or no? But tell
Yes,
me,
sir.
initially,
Yes, sir.
initially the objects were not moving; they are at rest. So the velocity was at rest. So what is initial momentum? Initial momentum is zero
0.
because they
Yes.
are not moving. No, basically gun and bullet. The gun is
Yes,
there
sir.
and the bullet is there here. Initially, any momentum is there because there is no momentum. No initial momentum because velocity is zero. When velocity is zero, obviously the total mv will be zero. That means p will be zero. That means pi will be zero. Yes or no? Yes.
Yes, sir.
But when the gun is fired, the bullet is fired, obviously you will have a momentum. That means called PF. Yes or no? So what is that PF? That PF will be what?
Yes.
MV
40.
minus MU. MV minus MU. And when we say that change in momentum basically. We say change in momentum. Change in momentum is constant. There is no change. Okay? Or change in zero basically when you say. So can we prove? Because there is no change in momentum. Momentum did not change. So let us substitute the value. What is M? M is 5 kg. What is V? V we don't know. We have to and small. This is small. Small M is how much? Zero point 0.2. And what is U? This is sorry. This is U. How much? 200 meter per second. Correct? Yes. But we have
Yes, sir.
to convert this into what? Kilometer per hour. How to convert? 200 into 5 by 18 or what? How to convert 200 meter per second? Tell me. No, no, no. So point two into 200 is how much? 40, no? 40, right?
Yes,
This
sir.
equal to 0, right? So what is 5V? 5V will be 40. What is V? 8 meter per second.
8.
Understood? Understood. The velocity of the gun will be how much? 8 meter per second. Yes or no? Obviously the gun
Yes, sir.
should be the gun should be more mass, no? Gun should be more mass, right? So basically when you say that momentum should be same, so here you see it is 40. If you multiply the same, here also 40. Yes or no? Yes or no? That means the
Yes,
mv
sir.
is equal to mu, means the momentum of the gun is equal to the momentum of the bullet. Momentum of the gun equal to momentum of the bullet. Yes or no? लग समझ में आ रहा है बेटा?
हाँ
Moment,
सर
momentum of the gun equal to momentum of the bullet. And you found out, yes, momentum remains constant. Why? Because see, 5 kg, the one which is having a more mass will go slow, will go at a lesser velocity. One which having a lesser mass will go at a higher velocity. Yes or no? Swaroop,
Yes, sir.
you see the bowler. I have another example. The bowler is running. Bowler can run in how much speed? Maximum 30 to 40 kilometer per hour or not? But when he releases the ball, the ball goes at what speed? 120 to 160, 150 kilometer per hour. Yes or no? Yes or no? That does not mean that bowler
यस
is going
सर
at this speed. That, since the ball is having a lesser mass, okay, the velocity will be more because this has the more mass. So the one which is having the more mass will have the less velocity. One is having the lesser mass will have the more velocity. Clear? Clear or not?
हाँ सर.
Yes.
समझ में? Shall we go ahead?
हाँ सर समझा.
Okay, we'll go ahead. So next we'll see spring force. So what is spring force? What type of force it is? What type of force it is? What type of force it is? Contact force. You are having a spring. You are having a spring. Okay. It will only, if you pull it, then only it will have a, it will, let's say you attach something here and you pull here, then only this will get pulled or not. That means you are actually giving a some kind of restoring force, some force, because of which it is actually coming toward this side. So more lesser you more you extend the spring, more will be the force. Yes or no? Yes or no? Yes. If I have a spring like this, if I extend it by 2 centimeter and the same spring, I extend it by 5 centimeter, where the spring force will be more? The spring force will be more here. Why? Because the spring force will depend on the extension. This is what? Delta X. Extension or elongation. So here, what is K then? It's called spring constant. What is called? Spring constant. It will always remain, it is a constant for a spring. It will depend on the material. It will depend on the material. Clear, guys?
Sir, is that K?
Sorry, K.
So K is also Coulomb.
K is a spring constant. Spring constant. Delta X is called elongation or extension. You can say anything. Elongation, extension. Yeah.
Sir, K is also equal to 1 by 4 pi epsilon naught.
No. Don't go by that. That is different. That K is different. This K is different. Don't get confused. That is different. This is the electrostatics. That don't get confused. This is different. This K here is called spring constant.
So what is the value of this K?
Spring constant is how much? That will be depend on the object. That will depend on the material. So I will check that. I think normally what happens, we are given to find out what the spring constant actually. Okay, if there is something which I'll tell you. Okay,
Yes.
so now
Yes.
let's say I am pulling this string by 5 centimeter. So spring force is something 100 Newton. Then we can find K, it will be F by delta X. Okay, F by delta X. Yes or no? Remember,
Yes, sir.
the force is always opposite to the what? To the extension. That means if I pull the string this side, the spring force will be this side. This is called extension. Let's say the same spring, what I am doing, I am compressing it. If I compress it, the spring will become small, and then the spring force will be opposite. It will come back again to the original position. So remember, the spring force is always opposite to the change, extension or compression. Clear? Swarup समझ में आया?
Yes, sir.
Yes?
हाँ, sir.
Okay. So let us say there is a spring. There is, here Swarup is standing and pulling, and here Laksh is standing and pulling. Both are pulling. Swarup is pulling. So this is getting pulled at x1. That means x1 का extension हुआ है. We got an extension of x1, and Laksh got an extension of x2. Then what is spring force? In this type of condition, remember, total extension how much happened? X1 plus x2. Yes or no? Total extension.
Yes, sir.
So your spring
Yes, sir.
force will be equal to x1 plus x2. Net extension how much? What is the net extension? Don't see one side. See the net extension is x1 plus x2. If it is in opposite direction. But what happened now? What Lux did? No, Lux was clever. Lux is actually now pushing it this side at x1. Swarup is pulling at x1. Lux has given a compression of x1. Now tell me, what is your FSP? What will be FSP? Who can tell? I can tell you will understood the concept. Tell me. Anybody guess? Yeah, come on. Opposite direction add hua. When you got opposite direction, it got added. In same direction, what it will become? Subtracted. I am talking about the net extension.
Subtract होगा sir.
X1 minus x1. That's it. That means the spring did not have, spring remained like that only because you are pulling. He is pushing. This guy is pushing. That means the spring will not change anything. That means the spring force will be 0 because the spring will not get anything. Nothing will happen to the screen. But let's say Lux is pushing at x1. You are pulling at 10 centimeter. Lux is pushing at 5 centimeter. Then what will happen? Then your FS will become how much? K into 10 minus 5. So net extension is how much? 5. So it is 5K. Clear, guys? Clear? Siddhi, clear?
Yes sir, clear.
Siddhi, clear?
हाँ
सिद्धि
सर, यस सर.
पहले पता था ये?
हाँ सर.
पहले पता था या नहीं पता था?
नहीं.
क्या 11th में क्या कर रहे थे?
पता था बट
भूल गए?
सर.
चलो.
हाँ सर, रिवीजन हो रहा है.
Okay. Now we will go to the next problem. So remember, in the opposite direction, the spring force will be net. Always remember the net elongation or compression. Net elongation, not individual. Net elongation. Same direction. FSP will be K into x1 minus x2. Always remember net extension or compression or elongate, whatever you can say. Note it down. Note it down. Note it down. So we'll do a small problem. There are two objects, B, A. Okay. The spring constant is K equal to 100 Newton per meter. It is asking find a spring force if both the blocks are displaced by 1 meter in same direction and 1 meter in different direction, opposite direction. Find out and tell me the answer. Find out and tell me the answer. First question is find Fs. First is 1 meter displaced in opposite direction. Second, 1 meter displaced in same direction. Quickly tell me the answer.
Oh sir.
Yes? So much time for an easy problem.
सर 1 मीटर एक्सटेंड मतलब कौन सी डायरेक्शन में हुआ?
अरे ऑपोजिट डायरेक्शन में बोल तो रहा हूँ. 1 meter extension opposite direction and 1 meter direction in same direction.
सर टोटल 1 मीटर.
बेटा 1 meter each बेटा.
Sir,
1 meter each.
200.
So first is opposite direction. Opposite direction means this 1 meter, this 1
200
meter.
आ गया.
So 2 plus 2 into 100 equal to 200. 200 Newton. Same direction. This also 1 meter. This also 1 meter. Already I gave an example. So 1 minus 1 into 100. How much? 0.
0.
So in same direction it is 0. That's it. सोचने का नहीं. सिद्धि लक्ष्य
हाँ
सर.
सर.
इतना टाइम लग रहा है क्या तेरे को?
सर मुझे मिल गया था आंसर.
तो बोलने का क्या है? बोलना.
नहीं, आई थॉट टाइम दिया है तो.
नो टाइम है तो बताओ.
Both of them were also solving ना, so.
That's okay. You can tell your answer, no?
सर मैं तो अटक गया था सर
Yes,
बीच में.
sir.
वो अटक गया था. इजी तो है. क्या है फॉर्मूला? क्या है? FSP इक्वल
सर
टू.
वो गलती.
तो गलती मत करना. गलती बहुत करता है तू. मार खाएगा तू. तो आ जाओ वापस. तीनों को बैठा के ना, तीनों के पीठ में दुम दुम करके छोड़.
सर आ रहा हूँ.
आ रहा है ना? जल्दी आ जाओ. सिद्धि को तो मार पड़ा है. चलो. Now let us go to the next concept. Okay. Now let us consider there is a fixed. There is something like a string. There is a string. Not a string. There is a spring. And you are attaching with a block. Let's say M. If I want to pull this, what will happen? You tell me. Ideally, what should happen? This will be oscillating or not? ऊपर नीचे होगा कि नहीं?
Yes.
Yes or no, Swaroop? Have you tried this? This will oscillate.
हाँ सर.
That means I am actually pulling. This is the equilibrium. This is the position when the spring is normal. I am actually pulling it. When I am pulling it, so 1 minute. This is the mean position when the spring is normal. I have not given any force. Here I have given force. That means how much elongation happened? Yes or no? Yes?
Yes, sir.
Yes, sir.
Yes, sir.
And because of what? Because of what? Because of the weight of the block.
Block.
Weight of the block. Moment, see in this position, I am actually attaching the block. And when I left, this, because of the weight of this block, this came down. So if I want to find out how much extension happened, how can I find? Delta X will be mg by k. How we got? FSP is equal to what? K into delta X. What is FSP? What is the force? It is because of the mass of the weight of the object. So mg is equal to k delta X. Then what is delta X? Mg by k. Clear? Clear?
Yes, sir.
So now let us do one more problem.
Yes, sir.
This is the explanation. Now let us do a problem, real problem. And with this, we'll end the class today. Tomorrow, same 8 o'clock, huh, guys? I don't have to call. You have to just join. Have you seen any time me coming late?
No, sir.
Right? So we have to find what is the elongation in the spring. So let us assume that a string instead of the spring. We'll assume this as a string instead of spring. So if you consider the first, we will consider this as a string. So what will happen? What will happen? The T will remain same or not? This will be T, this will be T. This will come down and this will go up. Yes or no? This will
Yes.
go
Yes, sir.
down and this will come up. So what can we write the first equation for this? 2 mg minus T will be equal to 2 ma. Yes or no?
Yes, sir.
But
Yes,
this
sir.
one will be T minus mg is equal to ma. Yes? Yes or no?
Yes, sir.
So can we add both the equation? So it become 2 mg minus mg is equal to 3 ma.
Yes, sir.
3 mg is equal to 3 ma. So mm cancel,
Yes.
3 cancel. Sorry. You tell no 2 mg minus mg is mg. No, how I got 3 mg?
MG. Yes.
So cancel. So we got 3a is equal to g. So how much is a? A is equal to g by 3 or not? A equal to g
Yes,
by
sir.
3 or not? Yes. So
Yes, sir.
can we find tension now? Can we find tension? Let us put down A is equal to g by 3. So 2 mg minus g tension. We have to find tension. 2m into g by 3. Yes or no? So 2 mg minus 2 mg by 3 equal to T. So here will become 6 mg minus 2 mg by 3 is equal to T. So we got 4 mg by 3 equal to T. Yes or no? Yes? Yes?
Yes, sir.
Now, so we got what? Tension equal to 4 mg. Now, replace the string with a spring. Replace the string with a spring. So what is the force? So your spring force is how much? Tension only. That means your 4 mg by 3 will be K into delta X. So what will be your delta X? The delta X will be 4 mg by 3. That's all. Understood?
Yes, sir.
Sir.
Easy. So what we did, we
Yes.
applied the pulley concept here. Normal concept, whatever we studied before, we applied here. Because here the force is what? What here there is no external force. Here only the tension. Because only the tension is actually pulling it up, and that is the spring force. Since it is pulling it, the spring will get compressed. Spring will get compressed. And what is that compression? 4 mg by 3. So an answer will be delta X will be 4 mg by 3K.
Sir, but it will be negative, right?
No, that we are considering delta X. No, I am not considering it is negative, positive. I am considering how much it will get. What is the change?
Okay. Okay.
Whether
Yes,
it is a
sir.
positive side, whether you are pulling it outward or negative, I am considering change. If it is 10 centimeter, it becomes 9 centimeter. I am saying change is 1 centimeter. Whether it is outward or inward,
Okay,
that does
sir.
immaterial. Yes,
Yes, sir.
clear, guys.
Yes, sir.
So I think we are through. All understood? No, that's what is important for me. Crystal clear, and you have to practice.
Yes, sir.
Yeah,
Yes, sir.
we'll see tomorrow higher concepts, and because very important.
Sir, so
Yes,
there
sir.
will be no class on Sunday.
No, now as of now, classes will be for 11th. It will be Friday 8 p.m. Saturday 5:30.
Start 5:30.
11th. For 12th, it will be for you and
Monday,
Caroline. It is Monday and Wednesday
Monday, Wednesday,
7 p.m.
7 o'clock.
So Sunday you can
Okay.
enjoy. Enjoy means
Okay,
what?
sir.
Study. No enjoyment at all. You have to study.
Yeah.
You have to score 90%. If you don't score 90%, you'll see me. Siddhi, मार खाएगी मुझसे. Okay. Good night, guys. Enjoy. Bye.
Good night, sir. Thank you, sir.
Good night, sir.
Bye.